So in this class, we'll be looking into the Terraform. Okay, one of the most demanding DevOps tool, even for the cloud as well. The same replica of Terraform you will find in AWS in the form of a cloud formation. Okay, so the basic task of these two is to provide or create resources on behalf of you through coding. Okay, that's why it is known as infrastructure as code, IOC. So the tools infrastructure as code, there are two basic tools. One is Terraform, other is Ansible. In this class, we'll be looking into the Terraform and we'll also compare why Terraform, why not Ansible. Okay, because both have a different purpose, honestly, but we'll look both into it. So these are our agenda for this class. What is Terraform? What is the Terraform used for? Difference between the Ansible and Terraform. We will do some hands-on and we'll look into the architecture and the commands and some configurations as well. So by the end of class, we'll be much more clear about all these basic topics of Terraforms. You can see there are a couple of refresh, plan, apply, destroy. These are the basic commands of Terraforms, which we will look. Okay. So let's
Okay.
start. The very first question that comes in our mind is what is Terraform and why it is being used. So, see what happens if I tell you to go to AWS and create EC2 machine, create VPC, create internet gateway, NAT gateway. Okay, you can go and you can create, right? But what if
Yeah.
I tell you that every day you have to create it? Suppose one resource get destroyed again, or you have to replicate the same resources on another IAM for another IAM user. So it will be very much hectic. If you see the VPC itself installation, configuration is very tricky. Now they provided a much more handy, but again to replicate the same, it will cost a lot of time, and again the precision won't be 100%. So for such cases, Terraform comes into the picture where you write code, and based on that code, you will get your infrastructure created. So if you second time, if you want to create it, just copy and paste that same code wherever you want it and then run it. That's it. That code will create all the tools or whatever the services you want to create everything for you. So through the code, you are managing your infrastructure here. So we are automating and managing our infrastructure. Okay. On your platform. Okay. It could be AWS, it could be GCP, it could be Azure. That is the benefit of having Terraform. It's cross cloud infrastructure, which means with Terraform, I can handle any resources of any of the cloud. But on the same place, if I use AWS Cloud Formation, I'll be limited to only AWS. With Cloud Formation, I can only do AWS infrastructure manage. But when it comes to manage GCP and Azure, I won't be able to do it. So that's the benefit of having Terraform and services that run on the platform. So whatever the services, if it is AWS, what could be the services? VPC could be the services, EKS could be the services, ECS could be the services, EC2 machine could be the services. So these services we can easily run it through our Terraform. Understood? What is the work of Terraform? Got it, guys?
Yeah, listen.
Okay. And the other two benefit is it is open source and declarative. Declarative means you declare your code. Okay, there is a imperative codes and declarative both. We will look into that one. And it's open source means you are not going to charge for using Terraform. So that's again one of the benefit of having such
Yeah.
a powerful tool and free of cost. In declarative, you basically define the end result. What do you want? Whereas imperative, you have to define every step of your creation. In declarative, I can just say that I need EC2 machine of this configuration. But in imperative, I have to define every steps, where to go, what to do, okay, what are the other steps, what will be the EBS, everything, which is much more hectic. So being declarative, it's get very much easier as well to create the infrastructure. And we will see also. Now, tools to infrastructure provisioning. What does it mean? Basically, creating, you have one app, then suppose the name of that app is my app. Okay. And you have been told to create infrastructure for this app. So if this app is connected with 5 microservices, okay, each microservices require different EC2 machine. So again, going creating, so it will be very much hectic creating and then putting the container over it, okay, Docker container over it, and the resources that we are using of AWS. So if you go and do it manually, it will be very much hectic for 5 resources, different configuration. On the same way, so these things you have to do: private network space, EC2 server instance, install Docker and other tools, and the security. All these things that you have to do by yourself manually if you do not use Terraform. But if you use Terraform, this one you can easily do it, okay, through the coding, okay. Even the deploy your application would be easier for you. So with Terraform, you'll be able to provision your infrastructure and deploy your application as well. Where to deploy, you have to tell where to deploy. So it will deploy according to you. So the two main things, so the only thing that you have to worry about here is your application. Okay, rest infrastructure development and the other part, you can easily do it. So earlier, what used to happen, deployment part, software developer used to look into it, and provisioning part, DevOps engineer used to look into it. But now, when it comes to create VPC, spinning up the server, create AWS services and permission, install Docker, nobody going to do it this much. Okay, means even the DevOps engineer as well. It's very much active for them because they have a certain this one hierarchy, and you have to create on the same way. Okay, you cannot create Docker and then VPC, because Docker should be created under the VPC. VPC basically under your region. Okay. And then without creating AWS user, you cannot have Docker in your server. Okay. So it's like this. This hierarchy also you have to maintain. So if you have to do 2, 3 times, it will be very much hectic to maintain the same hierarchy in the same order. So Terraform help us to provision all these things through your coding. Understood? So far, so good. Any
Yeah,
confusion
yeah.
anywhere?
No.
Okay. Now let's look a basic difference between Ansible and Terraform. Terraform, we have seen what is Terraform. With
Yeah, yeah.
Ansible, if I have to install Docker in 5 system, suppose I have 5 remote server and I want to install on that one, some updation I want to do. So I cannot go manually on each server and do it. For example, if I tell you, if I show you, suppose I have this one, remote desktop manager. Okay, so here these are the all servers. Okay, you can see how many servers I'm having, and under each there are a lot of servers. You can see for Oracle we have different servers. Means there are lot of servers. If some software I have to update in all these servers, imagine how much time it's going to take. Lot of time, right? It will take your whole day, consume whole day, and plus hectic, and the chances of error would be high. So for such cases, Ansible comes into the picture, and Ansible will help you to install your software on all those servers. Okay. So you understood what is the work of Ansible?
Yeah.
So if you have to
Can you repeat the
provision,
Ansible part again? Like I
yeah, yeah.
didn't get properly.
If you have to provision servers, okay, like the installation, updation, deletion of any task, you will use Ansible, but you have to create services on cloud. Here, these are the virtual machines. Okay. If I want to, the same thing, if I want to do on cloud, it will be difficult through Ansible. Okay. But with Terraform, it will be much easier to perform all those tasks with Terraform. So Ansible will help you if you have the remote servers inbuilt along with you. Ansible will help you to provision those servers by installing, deleting, updating the softwares already available on those servers. Whereas in case of Terraform, if you have the multiple clouds, okay, and you want to provision those clouds, handle those services of those cloud, then Terraform comes into the picture. Okay.
Okay. Like only Ansible is for like the like what do you say? Uh,
Provision the infrastructure of your
for
remote servers. It
okay,
cannot
like
create the VPC. It cannot create your EKS cluster. Okay, through coding, you cannot create it through Ansible. But the same thing, if
okay,
you want to create VPC, you can do it through Terraform. If so, these are the cloud services, right? So Terraform will help
mm,
you to handle the cloud services. But if I
okay,
want to update 10 or hundreds of thousands servers, then I will choose Ansible over Terraform. Okay.
mm-hmm.
I have a video on Ansible. You can just take a look into that one. You will understand more clearly. For example, in the previous, create VPC, spin up the server, install Docker, create AWS user permissions. So installing Docker I can do with Terraform as well and with Ansible as well. Okay, both I can
Mm-hmm.
do. But creating VPC, I cannot do with Ansible, but I can do with Terraform. Creating AWS user, I cannot do with Ansible, I can do with Terraform. Because Terraform is a cloud, it will help you to access the cloud services. Ansible will not help you to access the cloud services. Ansible will help you to provision the remote servers only. Okay. If you have servers,
Okay.
see, this is again a remote server. Okay. DP52 AVA29. And the one that I show you, DWPDB deploy 5, DWPDB deploy 4. These all are DW D123 del P. So these all are remote servers. Okay. And I want to install a particular, suppose Docker in all the servers here present. So I will use Ansible for that one. Okay. Any task I have to perform on all these servers, I will use Ansible. But on the same time, if I have to create services on cloud, then I will use Terraform. That's it. Understood? These all are not on cloud. Even if it is in cloud, I can handle through Ansible. Okay.
Okay.
But I cannot create the services in cloud using Ansible.
Mm, yeah.
Okay. I hope it gets clear, not too much confusing.
Yeah.
Okay, which one to use? Understood? If you have remote server only to manage, you will use Ansible. If you have cloud to manage, you will use Terraform. Okay. Both are infrastructure as code and both provision, configure, and manage the infrastructure. Okay. Mainly provision infrastructure provisioning tool, and this one mainly configure the infrastructure. Okay. Seems pretty same. But here the infrastructure is only the servers. Here the infrastructure is the whole cloud. Okay. You can deploy app, install and update software. That's the main thing. But here you can relatively do much more new tasks. Okay. It's more mature because it handles the servers. Okay. Directly servers it handles. Okay. And it relatively new because it's handle the cloud. Okay. More advanced in orchestration, handling the cloud infrastructure and all. Okay. If you have to configure the infrastructure, better for configuring the infrastructure and better for the infrastructure. Okay.
Mm.
Though you might not find a very distinct, too much of distinctness between Ansible and Terraform. But so far, whatever I have said initially, to manage the servers, whether it is remote server or physical servers, you will use Ansible. To manage your cloud, okay, no matter GCP, AWS, you will use Terraform. That's it. Nothing more. need to know. Okay. Even if you have the existing servers available and you want to do some changes on it, you can use Terraform as well for managing and for changing. For creating and changing server or infrastructure, you can use Terraform in both the scenarios. Okay. Replicating the infrastructure. Of course, if it is code based, so you can easily replicate any type of dev environment to prod environment to test environment. Okay, create the same dev environment, create a same structure on your prod, same environment on your prod. So you can easily do it because you just need a code, Terraform code for this one. And we will see how to do this one. Okay. How does Terraform connect to the platform provider? That's a question. So we will look at practically through AWS CLI. We can easily connect. Okay. So two things when it comes to Terraform code, you need to know. You should have a one file, tf config file. Okay. You have to create a main.config, main.tf or any tf file you have to create. Tf means Terraform file on which inside which you will write all your configuration for creating components in cloud. Okay. And this one, the current state of the setup. For example, what happens when you provide this tf config file or the tf file, it checks whether it is the state which is mentioned here already created or we have to create a new. Okay, so this one is getting tested on the state part. Okay. Once it get tested, based on that, what need to be created, updated, and destroyed, this core part does all these things. Okay. Based on the current state versus desired state. These two differences, this core part decides. Current state means whatever we have mentioned on this file is already available or not. That's the current state. If it is not available, then the desired state would be to create all these services which is mentioned on this file. Okay. You just required one file. Okay. And Terraform will take care of it. Terraform will check that state. Terraform will do the core part where basically create, update or destroy part will Terraform do. Okay. You just have to provide the command for it. Understood?
Yeah. Yeah,
Okay.
actually.
So this is the path for current state to the desired state. And the providers. You need to provide inside this TF file, you have to write provider. Means it could be AWS, Azure, okay, Kubernetes, Fastly. Means it's again an app. So there could be hundreds of provider. What do you understand by provider? On which this task will be performed. For example, AWS sorry, is one of the provider. What does it mean? It means this task will be provided on AWS. At the same time, you can have Azure as well, Kubernetes as well. Okay. So with Terraform, I can handle Kubernetes too. Fastly is again SaaS based. What is the full form of SaaS?
Service?
Full form.
Infrastructure asset.
What is the full form of
Mm.
AS, PaaS, and SaaS?
Uh, f- as uh, as is infrastructure and P means
Mhm.
provisioning, right?
Not platform.
Platform is for service only, I think.
Infrastructure as service, platform as a service, and software as a service.
Software. Yeah, 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 yeah.
So software means you are providing whole software to the user, end user. Okay, user
Okay.
don't have to do anything on it. Platform as a service, you have provided the platform. User have to now put the application on it and run it.
Okay.
Infrastructure as service means user have to configure whole infrastructure. You are just giving a platform like EC2 instance. I provided user EC2 instance. Now user will install all the application on it. User will make it compatible to for its application. Okay, like this.
Mhm.
So these are the services, nothing more. So over 100 of providers to over 10,000 resources. No, difference understood. Try to understand this one. Provider means it could be anything. It could be Azure, GCP, AWS, VMware, Oracle. Any can be provider. Okay.
Okay.
Services means each provider having thousands of services, right? For example,
Yeah.
AWS having EC2 or IM IM user as a services, right? So
Yeah.
you just have to provide two things: provider and resource. If you provide these two things, Terraform will understand in this file, Terraform will understand where to go and what to hit, what to create. That's it. Okay. So in Kubernetes as well, namespace, services, deployment. Okay. We looked into the services and deployment of Kubernetes. So as a provider, I'll provide Kubernetes. As a services, I'll provide namespace. Namespace also we have seen. Workspace was the space where everything was done. Services and deployment .yaml file where the requirements. You remember?
Yeah, yeah, yeah. Correct.
Okay.
That format was like that, right? The
Yes. So we created two YAML files in which we created one
yes, yeah,
namespace inside
correct.
that one. Okay.
Correct. Yes.
Great. So these things I can easily create using Terraform. I'll just provide the provider as Kubernetes. Okay.
Okay. Yeah.
Even for GitHub as well. Okay. So it could be your provider could be anything. You just have to execute the plan. So this is how the configuration file looks like now. Focus.
Yeah.
Provider I have given AWS. Okay. Version you have to provide and region you have to provide. Where will the resource get created? That's it. This is the provider. In place of AWS, you can write Kubernetes, you can write Azure, you can write GCP. Okay. And
Mm-hmm.
after this, if I have written provider as AWS, so what do you want to do in AWS? Then you create a resource. Provider is done. Resource. So I want to create a VPC. What is the name of VPC? Example. What is the CIDR block? 10.0.0./16. So it will create a VPC for you.
Mm-hmm.
Generally, version we do not provide. Okay. Region only if you provide, that's enough. That's it. That's our TF file. For Kubernetes, this is how it's look like. Okay. Authentication you have to provide auth info and the cluster name. What is the Kubernetes cluster you are going to have? Then Kubernetes namespace, metadata, my first namespace. Okay. Here we are not creating the state files. That is the services and deployment one. Okay. But it will create just a namespace. Means a space will be created for your Kubernetes cluster. Declarative, we have understood declarative. Just end task we have provided. See, these are declarative way. I only provided the end task, right? You have to create a VPC. That's it. I haven't provided anything else. CIDR block I provided, it's on you. You have to provide it. Okay. I have not provided it from where to go, how to create it, what are the other configuration for VPC. If you directly go and create VPC in AWS, it will be asking a lot of things. But here we just provided go and create VPC. That's it. That's a declarative way. If it was imperative, we have to provide a lot of things. Okay. So in imperative config file, it looks like this: remove to server, add firewall, add permission to the AWS user. You have to give a lot of instructions. Okay. But in declarative, just the end goal you have to provide. Okay. What is the current state and what is the desired state you want? That's it. Nothing else. So adjust old config file and re-execute it, clean and small config file because end goal you have to provide and always know the current setup. So Terraform aware of your current state Okay, whatever you are asking. So Terraform first go and identify whether the current state is already having such things or not. If it is not, then it will create it new. Okay. So this is the desired state of for your VPC. What you have to do? You have to refresh. The refresh part done by Terraform itself. Plan you have to do. Okay. So it's a command. Plan means it's a command. Terraform, plan, Terraform, validate. So we will look into that one. Terraform apply and Terraform destroy. Apply means it will execute your plan, and destroy means it will destroy whatever the infrastructure you have created using Terraform. Okay, and this is the infrastructure looks like. You provide your Terraform file, .tf file. Okay, use your command. Your command will create Terraform state, which basically contain all the logs or the history of your Terraform files. Terraform will go here, will configure your providers, and inside providers, it will configure the resources. That's all. Let's go. Let's do the lab time. Any confusion in understanding Terraform so far?
No, actually.
Let's take a- We have to create a resource for this one. Instance. Terraform Cloud, let's choose Ubuntu, P2 Micro. Simple, created a EC2 instance. Connect with the instance. Until it is getting created, let's open our Terraform. Okay, how to install Terraform? Let's go over here. So we are going to use Linux. Choose Linux. Okay, Ubuntu and Debian. So you just have to copy this one and paste it over there. We got this one. Let's do sudo. No need to do even this also. If you see the command, they have already included sudo apt update and sudo apt install Terraform, right? So both it will do
Yeah.
it. Just copy and paste it. So we understood this one. Now let's look into our Terraform providers. Terraform AWS provider. Okay, let's go here. Suppose what do we let's get something. Now see, you can tell what is the code is going to do, right?
Creates VPC.
Correct. Let's choose a simple one if I have for S3 bucket. Okay. If you write 3 4 provider, 3 4 for AWS or Azure, you will understood how to create. You will understand how to create it. This will create your IAM. Okay. And I'm looking for S3. See. So what this will do? this will create a S3 for you,
S3
right?
bucket. Yeah.
But it's a bit incomplete. They have not mentioned the provider. I guess we can do
Mm,
it still. Tag name and rest other things. Okay, no worries. We got our Terraform. Yes, Terraform is done. We created it. Let's check any file is there. No file is there. Now, what do you have to do? You have to connect with the AWS CLI over here, right? Because we are going to
okay.
connect with our AWS. So for AWS CLI, we configure for during our EKS. So install AWS CLI. Okay, just copy out this. You can easily get in AWS page. So no need to
Mm-hmm.
worry about that. What it will do, it will install it, the zip file, then it will install the unzip and do unzip task. Then we have to create one IAM user, which will having all the admin permission. Okay, for any tool that want to access your cloud, you need to use it as a user. So here I am having to, I can create another one. Let's create Terraform. Next, attach policy directly, and I'm going to give administrator access. Next, create user. Let's go inside this Terraform. Security credentials. You have to create the access key. Create access key for Amazon CLI. Confirm. Next. I need to provide the tag. So it will provide you the access key and the secret key.
Yeah.
It is still installing. We'll just wait for a couple of more. Okay, it's done. Use AWS configure. Okay. Now copy the access key and then copy secret key. Is to a default. If you want to confirm, you can just do this and see access key and secret key are both taken. Great. Now you have to create a TF file, okay, which will contain your Terraform state. So let's create it. Bin main.pf. Let's name it. Yeah, I'm going to copy this one. Paste it over here. AWS S3 bucket. Bucket name is example. But need to provide the resource as well. Provider. So that was mentioned. Should have been mentioned. So let's try to run it because we have this AWS CLI, so it's work or not. Let's see. Command is Terraform init So it will initiate Terraform. See, it has already taken AWS version 6.1.6.14.1. We need to mention the provider over here because we are already using AWS CLI. Any question? You can get the provider of everything. AWS provider,
Mm-hmm.
if I look for Azure. Okay. But in company wise, they'll be having their own, like they will
Okay.
create this one by themselves. So you have to look over there.
Means like the documentation they'll have like separate,
Yep.
you're saying?
Yeah.
Okay.
Here we are creating like this one. S3 we are just creating it, right? We are not
Mm.
specifying few of the basic based on the industry understand standard.
Mm.
So they'll
Yeah.
be having their own. Okay, no need to worry. Terraform has been successfully installed. Okay, initiated. Great. Now this next command is Terraform validate. Let's do ls. Okay. AWS. Still we have only main.tf. Okay, our main file. Let's do Terraform validate. So if anything wrong in your TF code, this will tell. Okay. So nothing is wrong.
Mm-hmm.
So it passed. Now do Terraform plan. So this will generate the plan, how it is going to configure your the resources that you have mentioned in your TF file. And then, okay, there is some error. Yeah, okay. So we have not provided the region, planning Terraform encounter, generating this one. No worries. Let's do again main.py. I'll just take the provider from there. This part. Hmm. Provider. Yep. Done region is this. What is the region over here? US East 1, US East 1. WQ. And Terraform validate. Then Terraform Terraform plan. Generally, the best practice is to create a separate folder and put your main.tf file over there. Okay, because if you have two, three TF files, it will get confused. Now it is not giving any error, right?
Yeah.
So bucket name is given my TF test bucket. Okay, the name would be example. Your bucket name would be example. And all the basic environment, rest of the things, versioning. See, it enables the bucket versioning as well. Okay, even you can do it separately. You have to provide all the things it has mentioned. Basic. Now do Terraform execute. Apply. So whatever the plan we created, we have to just apply it. Creating S3 bucket, operation S3, HTTP response. What's the issue? Okay, so it is saying the region US East one cannot create over here. The
So,
accepting is US Central one. Hmm.
the one which we did is like US's one, right?
Yeah, US East one. Why the authorization error is there? Okay, can you tell me the reason? The
No,
reason,
actually, yeah.
because the example is a very common name. You have to provide a unique name for your S3 bucket.
Okay,
Okay.
okay.
Always provide because it is going globally. So it's just like a DNS name.
Mm-hmm. Okay. Yeah.
But yeah, so you need to provide a very unique name. Sample 5, 6, 9. Yeah, set double zero as well. Cloud. Hope this should work. And name is not having any conditions. Okay, bucket name must be 3263. Valid character, all the characters should be in star small and 0 to 9. And hyphens, we can provide the hyphens. So everything is small, yeah. So again, start from the first. So even sometime you face challenges while creating the resources. Remember the what are the
Mm-hmm.
rules for creating the resources. Okay,
Mm.
sometimes you are all correct, but still the rules you are not going according to that.
Like if like we can give that error to the chat GPT or Copilot,
And
then we'll get.
yeah, they'll
Yeah.
easily tell you.
Yeah.
So the only thing that you have to correct is your Terraform state file.
Mm.
What is the other issue? US East. When is wrong? API authorization, header mail request. Line number 5. There is some. Let's try with this one. I have to check. Yes. Give me few minutes more. We'll get the confirmation. Is it recording invalid? Version. Version. Yes, that is right. Yeah, I missed double quotes. This time it won't be there. The warnings, don't need to worry about the warning. Okay, so the resources here got
Yeah.
created, and we can look into our VPC. Two VPC got created, but why the name is not here?
Okay.
Creating completed. Okay, this is the name. Okay, VPC 040F 40F. Here it is. Okay,
Mm-hmm.
so name might be it is we have to give separately. I'll look into that one. But so far you have understood what is the process of creating the resources.
Yeah.
Okay. So in this way,
Got it.
everything will be created like this. Just you have to, if I do ls right now, you will see couple of more files got created, two more files. Remember, okay,
Mm-hmm.
you just created only this main.tf file, but terraform.tf state and terraform.tf state backup. So what this will contain? This will contain all the logs of your whatever you have execution required for this one. Like when you do Terraform plan, all the things store over here. Okay. And the backup of this file is this one. So if some by chance your main.tf file got deleted, so you can regenerate through this one. If this one got created, because for number of TF files, you'll be getting only one TF state file. So if this
Mm-hmm.
one will get created, you won't be able to regenerate it, your new one. So now onwards, it happens as couple of days back, couple of month or year back. Because initially when 4 or 5 years back when I learned this one, only these two, only this file got generated. You won't see this file. But nowadays they made this one
Okay.
too. A backup of your TF state file as well. Okay.
Okay.
This file contain all the history of your main.tf file, and this is the backup of your history file.
Where this TF state backup file will be?
Here it is. Both the location. If you want to see, you can just do cat. They are in the form of JSON. And just copy and paste. So you can see this is the JSON format of that.
Okay.
So pretty difficult to read out. You can
Mm-hmm.
understand just that it is working on VPC. Okay.
Mm-hmm.
And the VPC name is example cloud type of.
Okay.
Okay. ARN number is required, which tells what is the location. Okay. Which EC2 instance is being used. Then VPC, what is the CIDR block? Okay. Can even go and check. See, the CIDR block is same 10.0.0
Mm-hmm.
slash section. Okay. You should have created the name as well, but I guess it might require a different field for the name.
Mm-hmm.
Okay. No worries. Explore it more. In the same way, if you have to do for Azure, if you have to do for GCP, do it in the same way. Okay. Nothing changes. The rest for command TF init, TF to validate, TF means Terraform plan, and Terraform apply. These four will always remain the same. The only thing changes is your main.tf file. You can name any file. Okay. The best practice to create folder and put this main.tf file inside it. So these three will be separate in a single folder. So, and try to do for the S3 bucket. I might be missing few of the things. I'll take a look into that one. Okay.
Okay.
So any further questions?
No, actually.
And I have included almost all different type of scenario based question that could be
Uh-huh.
asked in this.
Okay.
So I'll see. Total 15 question. You have an existing structure along with the solution. Okay.
Okay, sure.
I wish I had more time, so I would have explained.
No problem.
But the next class I'll take off this Azure. Okay.
Okay.
So you guys will get to know. And I was thinking to go with SageMaker as well. That is AIML one. But
Mm.
which one you suggest? I'll do that one.
Uh,
If you can cover this one Azure through YouTube, then I'll go with that one. Otherwise, we'll look into
okay,
that.
let's
Just stop it for now.
uh